Hello and welcome to the video that is going to explain the origins of the Tharsis region of Mars and specifically focusing on Olympus Mons and the Tharsis volcanoes as well as Valles Marineris. Okay, so in the discussion you were asked to identify what the tectonic setting was of each of these landscapes and try to explain their relationship to plate tectonics and such. So let's first start off with Olympus Mons. Olympus Mons is right here where you can see my mouse actually highlighting. It is the largest volcano in the solar system. It is a shield volcano, indicating that it has a basaltic composition. Now, what you see here are you see these linear features of three of the Tharsis volcanoes themselves. And so the question is how did these volcanoes form? Well, the first thing that you're going to notice is you, of course, do not see any trench or anything related to these features. So, of course, this is going to automatically lead us to these volcanoes formed as a hotspot. Now, the question is was it one hotspot that formed and then, maybe the plates moved over? Or is it more like multiple hotspots? Well, here's the thing. Whenever you look at the surface of Mars, you don't see any indication of what we would call plate tectonics. So because of this, you would have to presume then that Mars does not have plate tectonics, which then leads us to deducing that these were actually formed by hotspots. And based on, there's no real pattern to these, and because we do not have the age of rocks, which would help maybe tweak our interpretation a little bit, we would have to presume that these volcanoes were formed by multiple hotspots. So there's the tectonic setting of that right there of each one of these. Now, whenever we start looking, at this region right here and we see that this is an elevation map, we notice that this entire region that I'm highlighting here in red is actually a higher elevation than the surrounding landscapes, which are in blue, yellow, and green. Okay, well, this is due to that mantle plume or hotspot uplifting and stretching the crust. So you can see up through here to the due north of the volcanoes, you can see a little bit of stretching of the crust up here. I would presume these are probably some Graben features, which you're going to learn later in the course. But one of the major things that you see right here is this large crack going across. Okay, now most people would presume that right there is either a river channel, so students compare it to the formation of the Grand Canyon, or their other presumption is that this is more like a rift valley, like a divergent boundary. Well, here's the problem with the divergent boundary theory. Okay, the problem with the divergent boundary theory is Mars doesn't have plate tectonics. Now, you are partially correct in stating that it was pulled apart. Okay, but here's what actually happened in this landscape. Whenever this magma plume that was beneath the crust actually pushed up on the crust, what it did is it kind of ripped this area open. So yes, it does have some divergent qualities, but it really was just the mantle plume kind of unzipped this area is what it's always kind of compared to. Okay, and that's how you get the Valles Marineris formation. It's basically the crustal stress just caused it to break open, much like a rift valley would in Africa, for example. Okay, so, but it was not related to plate tectonics. It wasn't being pulled apart by the plates. It was the mantle plume just stressed the crust so much that it actually cracked open. Now, the other thing that I want to go ahead and explain while we're here is we're looking at why isn't this like the Grand Canyon? Why wasn't this formed by maybe ancient water that was on the Earth's surface? Well, the primary thing that you're going to look for here is how you differentiate fault system cracks in the crust as compared to water erosion in the crust is you notice that this is very linear, and whenever you see linear features, that tends to be fault related or tectonic related, we'll call it. Not plate tectonics, just tectonic related. Notice how these are very linear up here. And then you look over here and you say, notice how they're very sinuous or windy. Okay, that's water related. So that's how you differentiate and can infer that Valles Marineris was not formed by water erosion. So that right there is the explanation of how Olympus Mons and the Tharsis volcanoes and Valles Marineris formed. They're all in relation to this large mantle plume or hotspot beneath the Earth's crust. So I hope this video provided you insight and understanding of how these landscapes have actually formed and how they are related to plate tectonics and volcanism.